Hello guys, welcome back to the channel, and this is the third video where we are teaching on how to integrate such problems without the use of bypass using a method that is more easier and faster than bypass. So thank you for showing up and I hope you enjoyed the video. Okay, so on scenario number 3 we are going to choose this example, e to the power x cos x dx. Right, so this is the example that we are going to use in this scenario. So we are not using by parts, we are using our method D. We create a table I. Right, so now you need to make a choice again. Which one should I integrate? Which one should I differentiate? So in this case, I'm going to use e to the power x for my differential and cos x for my integration. Right? So if I differentiate e to the power x, I'm going to get e to the power x. I'm going to get e to the power x. Here, if I integrate cos x, I'm going to get sine x. If I integrate sine x, I'm going to get negative cos x e to the power x. If I integrate negative cos x, I'm going to get negative sine x. So it will continue and continue, and we don't reach a point where we get 0 like the first scenario, or where we get a row which we can multiply and we get something that doesn't require integration by parts. So likewise, we are going to put our plus, negative, plus, negative. So this type of a scenario has its own way of doing. So we are going to look for a row that gives us, or that regenerates our question. So our question is integrate e to the power x cos x, right? So we are going to see, so besides this one, we need another row that generates the question. So this one we are leaving, it's out, this one it's out, this one, right? So we reached here where we say e to the power x negative cos x. We are not taking into consideration the signs, we are just going to take the expression. This is what we consider. So we will stop here. This is our stopping point. So I hope you are understanding the difference in our stopping areas. From the second example, we gave a different stopping strategy. The first is its own strategy. So if you come up with a mathematical problem that falls in any one of the scenarios, you just know when to stop. So in this scenario, we stop when we have generated the question or regenerated the question, but we don't take into account the signs. Right, so we are going to cross multiply. So e to the power x times sine x, negative e to the power x times negative cos x. Right, so we are going to say integral e to the power x cos x dx is equal to e to the power x sine x plus negative times negative plus e to the power x cos x. Again, we multiply with the integral of the row, right? So we say plus, so it's negative, sorry. So we're going to say negative because it's positive and negative. Negative e to the power x cos x is integration, so plus dx. So at this stage, we are going to, as you can see, this is a like term to this one. So we are going to add them. So we end up with 2 integral e to the power x cos x dx is equal to e to the power x sine x plus e to the power x cos x, right? But our question is saying integrate e to the power x cos x dx. So we are going to divide by 2. E to the power x cos x dx is equal to half e to the power x sine x plus e to the power x cos x plus c. So this is all about this method. So just take note of these 3 scenarios. If you are given any question, just try to think of where it fits and you can solve the expression, or you can solve the problem. So that's it for this method. So if you're given any question, just try to think of where does it fit. Does it fit the first example, or the second, or the third?